CircuitPython Day, we code and play the open source way. CircuitPython Day, we code and play the open source way. We code and play.
Code, play, code, play, code, play,
The open source way. CircuitPython Day, we code and play the open source way.
Hey, all right, let's get this thing going. Hi, it's me, John Park, and I'm here for John Park's Workshop Special Edition, Special CircuitPython Day 2024 edition. Thanks, everyone, for joining. As you know, I usually do this show on Thursdays, but everything is CircuitPython Day today. So we have moved a bunch of shows here, including me. So here we are. It's Friday. Thanks for stopping by. Thanks. I hope you've been enjoying. I've been able to catch some of the streams that have been going on. Amazing stuff. I can tell from the chat over in our Discord that I've got to go back and watch Charlene's stream that Liz did showing some of her amazing projects. So that's a thing to look forward to there. So what do we got going on here today? I don't really need to shift things too much to participate as a CircuitPython Day edition because I already do a whole lot of CircuitPython on the show. So it'll be mostly normal with a couple of exceptions. So first of all, if you want to go get some stuff, if you want to go to the store and buy some things at a lovely discount, we have one all-encompassing 16% off discount here today on CircuitPython Day, and it is that right there. 16% off code is CPD16. CPD16 stands for CircuitPython Day. CircuitPython Day 16. Today's the 16th. And 16% off. That is good. What does it say there? Today all the way through till the end, right? Till midnight tonight, East Coast time. So you can go here. Go to this place. Look. Oh, I broke it. I broke a thing? Why did I break that? Let me go fix that. That is... Hang on. It's going to be the Adafruit site. You probably guessed, right? That right there. If you go there, if you go to the Adafruit site, you'll see it. In fact, we've got a banner up there that has the coupon code listed as well. But go check out some new products. Go check out the this link right here. What's new? Right up at the top. If you click that, see some of our latest stuff. A couple things have gone in since like last night. In fact, I think 3 or 4 of these up at the top were not in stock yet. But now if you want to go grab one of those universal reversible type A connectors for USB, we've got that little breakout there. That's new. You'll get 16% off if you use that coupon code. And scroll through here, you'll see a whole bunch of stuff that's been coming out lately. Even with the move, even with Adafruit moving from Manhattan to Brooklyn, there have been new products coming out, as well as, of course, any of the oldies and goodies. So you can go through here, head to the products, browse through categories, find some neat stuff, and get some discounts using this right here. That's the coupon code that's going to get you 16% off today only. So yeah, I mentioned the Discord. That's a good place to come and chat. If you are wondering where we are, we've got a chat over in our YouTube, and we're keeping an eye on that. We've got this universal chat for everybody right here in Discord, and we don't keep an eye on Twitch and some of those other places. I don't think for some reason Facebook is wanting to play along today. It's acting like I'm not connected to it, so no Facebook for this show today, sorry. But if you head to one of these other places, you're wondering where the chat is, come on over to our Discord. You can get there by going to adafruit.it/discord. And thank you. Hey, it's Blitz City DIY, it's Thin Man, and then we've had a bunch of people who've been around hanging out all day, so hello to you all. Rufus, Some Nice, Paul Cutler, and Toddbot, who did a great show earlier. Thanks for that. Foamy Guy, who's going to be doing some live game dev development hacking in CircuitPython later today, I believe. And more, much more. So you can go back through the YouTube, head on over to the YouTube, and you can see all the shows that we've done today and catch up on those later. So what have I got? Hi, Eric Hess over in YouTube. Thanks for joining. Happy CircuitPython Day to you too. By the way, look, I've got my Blinka pin on there. Very proud of my little Blinka pin there. We had that. I think that was in maybe AdaBox 8, one of the early ones, fairly early one. We had this little Blinka pin, Ouroboros style, eating her own tail. So next up, what's happening here? I've got a show I do on Tuesdays. It's this one right here. It's the product pick of the week, and on this I check out something. Oh, I didn't update this. This is the wrong one. Okay, you get to watch me fix stuff in real time. Hang on here. I thought I set this up. I did not set this up. Hang on. That was last week. Let's see what was going on this week. It was that right there, the one-wire adapter. Let me go fix that movie too. It's going to start the wrong one for a second. Hang on. That's the product pick this week. It is the RS-232 PAL. It's a UART to RS-232 breakout. I have a little box over here that is an HDMI. It's this. It is the DS2484 I2C to one-wire bus breakout. Here is the DS2484. Connected to it, I have a one-wire temperature sensor. Now I've got I2C to one wire, and I can use this type of sensor right on my computer. To do this, I'm going to use Python. In the Macintosh terminal, I'm saying Python 3 code.py. It'll run that. ROM ID, and you can see it there, 287D, blah, blah, blah. And then it's going to start reporting the temperature. And plunge that into this ice water. We should see this start to drop pretty rapidly. I'm checking it every second. So there you can see 69 degrees, 65, 61. In the middle here, I have some very hot water. So yeah, around 189, 190 degrees. The DS2484 I2C to one wire bus adapter. Yes, that was product pick of the week. I will not be here next week. I've got to go out of town, so there will not be a product pick of the week on Tuesday. There will be the following week. Same goes for Thursday. Show won't be happening, so I'll be out next week. But tune back in a week from Tuesday for the next product pick of the week. And keep in mind, if you can watch the show during the show live, that's when we have the discount, usually 50% off on the product pick, limit of 10 per customer. So stop by for those if you can. Let's see, next up, let's take a look at a fairly appropriate for the day CircuitPython Parsec. Here we go.
CircuitPython Parsec.
Okay, I believe we're set up, yeah. So this was actually, I was planning a different thing, but this morning during Dan and Scott's talk, they were asked a question about some of their favorite development boards, and I believe Dan said the MacroPad was one of his favorites just because of all it can do and all of the UI that you have on it. So I switched what I was doing to show a pretty neat feature of the MacroPad and its library. So on the CircuitPython Parsec today, I wanted to show you how you can use the automatic rotation on the MacroPad. So here you can see I've got a MacroPad set up and I am displaying an image. I have a little Blinka image on the OLED here. And you can see as I press the keys, it is telling us which key I've pressed by number. And with each of those keys I press, I'm moving my little image a different amount based on the key. Now, one of the cool features here in the library is I can set the rotation of the MacroPad with a very simple command to any of the 90-degree angles. So in this case, if I'm using the board sideways like this, you'll see just by that one change, I now have a rotated screen and my buttons have also been reoriented, so I don't have to deal with remapping those. So you can see in the code here the way I'm doing it, I'm simply importing MacroPad, and then I have a little case here. If it's side mode true, then I'm creating the MacroPad object with a rotation set to 270, and I'm picking a vertically oriented BMP file. In case I set this to false, then MacroPad is created with a rotation of 0, which is sort of its normal up and down state, and pick the appropriate bitmap there. Wouldn't have had to do that if I used graphics or text, but in this case I'm using an image for CircuitPython Day. Then you can see in the main event loop here, all I do is say check all the keys. If one gets pressed, then we're going to simply move the image based on that key. As I press them, they're printing out the key numbers, so this in the upper left is 0 all the way up through 11. If I flip this back around and resave the code, you'll see that these are now back to traditional orientation. And so that is how you can set the rotation of the MacroPad in one command, and that is your CircuitPython Parsec.
The CircuitPython Parsec.
Hey, good thing I was finished, because right as I finished, I hit my I hit a key. I don't know which one, which made the REPL disappear. What one key makes the REPL disappear inside of here? I don't know. Let's bring it back. I don't know what key that was. Key combo? It's mysterious. I have no idea how I did that. Huh. Don't do that again. I will try not to. Yeah, so let's see. That is my little CircuitPython Parsec for you on our lovely little MacroPad there. And this is based on a couple of the examples in the main guide. If you take a look, we have this Blinka image is in an example code for MacroPad library. You can do stuff on the MacroPad without. You can use any of the display I/O things. You don't have to use the convenience library. But this is pretty cool with this convenience library. You set the rotation, and not only does it change your screen rotation, but it also changes the button ordering and the NeoPixel ordering. So really easy to get up and running with that. You can do a lot with it. All right, so then what I've got next, I want to show you a new project that I'm starting on. And it is over here on the workbench. I will show it there and explain it a bit, and then I'll head over and demo it, but I think this is a good way to talk about it. So what you can see there at the bottom of the screen, I have a feather, and this is an ESP32S2 reverse TFT. So you can see we have a lot of room there for the screen and some buttons. Plugged into it, I have two Stemma QT connected gizmos. One of them is the INA219 high side current sensor. And so that is being used to measure the current draw of whatever I have plugged into the thing. What I'm using for power is the USB-C power delivery dummy. That's the gizmo over on the side there with the white USB-C cable plugged into it. So that is using a power delivery capable wall wart. You can see that Anchor Prime one there plugged into it. And being USB-C power delivery, it can give a device whatever voltage it asks for, or within the limits of what it's designed for. But usually that's going to be your computer or some other device is going to negotiate for the voltage it needs and the current that can come with that based on its power. So in this case, that one can give us fairly standard set, which is 5 volts, 9 volts, 12 volts, 15 volts, and 20 volts. Now that little gizmo can be set with some jumpers and solder to be a particular voltage, and then it's just kind of set it and forget it. But you can give it commands over I2C inside of CircuitPython to tell it, hey, be a 5 volt, be a 12 volt, be a 20 volt. Now what I've done in this case is I've strung these three things together so that I can make essentially a little benchtop power supply that can give me any of those voltages, particularly useful for little gizmos and devices and motor things and light things and music things that I want to plug into it. And yeah, thanks, Scott Shawcroft points out over in the YouTube chat, and it's on a swirly grid. I love those little swirly grids, particularly for the microcontroller plus a couple of Stemma QT thingies all bolted onto it. I'll show you how that's set up in a second. And then I'm using the feather to pick among my possible voltages, and then I'm reading the actual current that's being used. So I'm going to head over there and show you it in real life. Actually, I'll keep that window large. And I just got to zoom this one in. This camera continues to want to die from the heat. I don't blame it. Let's get in closer there. And I'll show you this in action. Okay, so you can see here, I've got 5 volts selected right now. And you can see here, I've got an analog meter just so it's easy to see. And I'm going to plug in a little light ring. This is a 9-volt light ring. And we'll see, I might need to not point it at the camera, we'll find out. So right now, even though this is attempting to send 5 volts, I actually have a physical on-off switch in line there. Okay, so now it's just grabbing 1 milliamp. This thing doesn't really want to light up at 5 volts. It's meant to go at 9. So what I'm going to do is I'm going to hit one of my buttons on the feather, and that you can see in parentheses or brackets there, it says, oh, hi, that camera's kind of pointed down. I'm going to squat down. That says, okay, 9 is what's going to happen if we hit OK. So I'm going to hit OK at the top. And you can see there, yeah, that's really bright, so I'll turn that down. And my physical meter here, this one's not calibrated, but it says roughly 9 volts. And you can see here I'm drawing about 400 milliamps right now. So if I just disconnect the light here, I'll do it this way, in fact, you should see that drop to close to 0. Right, it's just grabbing 3 milliamps right now. Plug that back in, and it has a pretty substantial draw for all those, and it's pretty bright light, you can see. This is meant only to go to 9, but I've pushed it to 12 without it instantly bursting into flames, so we'll try that. So I can select 12, and I'm using these 2 buttons to go up and down among my possible voltages, and you can see it's not switching until I tell it to. So I should probably not go to 15, definitely not go to 20. I can loop through, or I can go down this way. So when I hit OK up here, it is going to renegotiate via the power delivery dummy, and this is the HUSB 238, I think that's its name. So that chip can go and ask my power supply for the 12 volts. So I'll say OK. Boom! Quite a bit brighter. Now it's drawing 2 amps. So I'm going to drop that down before I burn things out. Okay, we're back down to half an amp on that. Now I can push things further by just hooking up this fan. This is a little, I use this for a solder exhaust fan. You probably can't really see it or hear it, but I'm gonna send this up to higher voltages just so we can see what happens. So I'll go up to 12 volts on it. I can hear it, it's going a little faster. 15, yeah, and you can see we get the analog meter there. All the way up to 20, Yeah, it's really putting out some wind. Woo! Back here, it's sucking that air through. And this one actually will run at 5, so I can go back down to 5, and that's spinning still. I can turn it off, and you should see the fan stop. You can see it there, so I'll turn that back on. See that spin up. So this is something you can couple with a really cool little kit we sell. It's called the 30-in-1 laptop adapter. This covers so many of your possible weird DC barrel plug situations. It's fantastic. I definitely run into a couple things like some of these really skinny Sony device ones that are like this. All of these plug into a regular, I put it in quotes, the regular barrel connector was a 2.1 millimeter that we're used to. So if I unplug this right here, we can adapt. So I've got my little project here with just the sort of normal, most standard one that I run into. This adapts that up to any of these 30 possible styles. Now, I believe, I haven't tested this, but I'm pretty sure these are all, none of these are switching polarity. I should double check that, but I think they're all designed to just keep the center at whatever it was and the sleeve at whatever it was. So I have this set up for center positive, and that's one thing I'm not doing here is I'm not trying to make this switch over into like guitar pedal world and go center negative. Might be interesting to set up a kind of switch to be able to do that, but that's beyond the scope of what I'm trying to do here. So that is it. That's what it looks like. What I'm going to do now is I'll unplug this and bring it over to the workbench so you can see what's going on in code. It's fairly simple. So I'm going to unplug power, and I will bring this wall work because some things won't work if it doesn't actually have the power delivery chip messages coming on the other side of it. So let's switch back over here, and I'll go to the desk like so. Okay, so I'll give this the power dummy is getting the power delivery, the PD charger, and then into the computer, I'm just doing power and data for the Feather and these over I2C, getting their info there. And let's update this with the code Pi running on the board there. And so one of the nice things about this is I built this pretty much yesterday and coded it based on just a couple of example code snippets in CircuitPython. So it's pretty straightforward to put this kind of thing together, especially because we're using a couple of breakout boards that have libraries that have example code. So I'm going to reconnect my REPL here, and you can see here I can adjust. So right now I push this down, it says, okay, your voltage will be set to 5 volts or 20 or 15, and I'll hit go and it'll say, okay, setting it to 15 volts. It is set. And I think, yeah, let me plug something into it. So I'm going to plug this fan back in. Actually, you know what? I'll do the light, since you can see that one. I'll just stay away from dangerous voltages. So you can see I've just got like a little pigtail barrel connector. Oh, good. That's not... Hey, I'm glad it didn't burn out. Did I really just end at 15? It survived. I thought this was off. Okay, so let's... Good, you can see that. That'll work. So what I'm going to do is just for a moment here, uncomment a bunch of nice info we can get off of the INA 219. So let's set this back up to 9 volts and turn that light on. Oh, yep, there we go. So now you can see, while I'm reporting on the feather the voltage that I'm asking for, and that's just in these simple integers, 9 volts, 12 volts, 15, the INA 219 as a high side current sensor can tell us things like what is the input voltage and the shunt voltage, or the voltage that's actually making it out the other side. They're basically saying here 8.965 and 9.02. The current draw, and then this also does a nice little power calculation. So we're drawing 5 watts right now. If I drop this down to 5 volts, now we're at 0.004 watts, and that's basically because this doesn't really want to be driven by that low of a voltage. So let's go up to 12. Oh, what did I do? I think it wasn't ready. I should say I haven't put any error correction into this yet, so if it fails, it just bails. Let's go back up to 12. There we go. Now it's 28 watt is the power register. Let's drop this down back to 9. And I'll turn that off there so I don't accidentally burn it out trying other stuff. So this is all based on, if we go up to the top here, you can see just a couple of libraries. So I'm using the HUSB 238, which is our power delivery, and I'm using the INA 219, which is how we're reading that high side current draw. Those are all set up on I2C. And then I'm just doing a couple of setup for buttons on the TFT display there using keypad. And then I initialize the INA 219. I initialize the hub HUSB 238. And when it first starts up, if you see here, I'll press reset, it will print out the available voltages. So it actually, let me turn off this print down here so that it doesn't fly by. So you can see when it first starts up, it will ask that power supply, hey, what can you give me? And in this case, it can give 5, 9, 12, 15, 20. And it also says what it's currently set at, which is 5 volts delivering up to 3 amps. If anyone knows, I haven't used these kind of power delivery chargers much. This is, I think, there's only 2 of them that I have. One of them was an Apple laptop supply, and I can't remember what that one will supply, if it's the same. But has anyone seen other voltages? Does it do different power delivery power supplies offer different voltages, or are these kind of a standard? I'm not sure. Or is that just related to what we have on the HUSB 238, and the supply can give whatever it can ask for? I'm foggy on all that stuff, so I'll look that up before I talk about this again and work on the guide. But if anyone knows, I'd be curious how that's supposed to work. So let's see, going back up here, we set up both of those devices, and then this is one way I'm going to do some error checking, is this if power delivery attached. So you can tell it to not bother doing things if it doesn't actually receive that little handshake on the other side. So if you plug in a regular USB supply that doesn't do power delivery, we don't want it to fail, we just want it to pass through the 5 volts. That would be standard. Hem over in the chat says not all voltages are supported by all chargers. I believe some chargers offer 18, but aside from that, I think you have all the standard voltages. Okay. Thank you, Hem. Appreciate that. All right. Yeah, Liz confirms that. So 5, 9, 12, 15, 18, and 20 are what you can get, but this one that I'm using, which is an Anchor, doesn't appear to have the 18. So then I'm doing a little bit of display setup for the little reverse mount TFT here. I've set up some variables for some colors I want to use. So, for example, when I'm picking among voltages, I go to this kind of yellow color, and then I go to this purple when I accept that color, and I'm using this magenta as my color for the current. I have a little background color set up there. Do some display I/O stuff. I'm thinking about adding more little user interface elements just to keep it clear as far as what the buttons do. So maybe some circles, that kind of thing. But I won't get too crowded with it. And then I've got two labels that I'm using in this case. So the voltage label and the current label. And that is it. Add those to the group and show the display group. Todd suggests that I ask for 1.21 gigavolts. That's madness. Then in the main loop, I check for buttons. So if the D0 button, and by the way, I have to set these up separately because the D0 goes high and the D1 and 2 go low, or vice versa. So they can't in keypad be set up as the same members of the same keypad object. So I actually have two keypad objects. But here you can see the D0 one, when that gets pressed, I can use whatever voltage of those, however many are available, that I'm currently cycled through. So this V variable is just being incremented or decremented as I press it. So whatever V equals is what we will set to with this command here, PD voltage equals, and then voltages, and then it's an index of the available integers. And then in the case of the other two buttons, those are just simply incrementing or decrementing that V variable and then changing what the display says. Bus voltage equals INA 219 bus voltage. So that's the INA 219 checking to see what's coming in. Shunt voltage is what's going across the shunt. Current and power. And those are all what we're using to print here. The only one that I'm actually using is on the display is the current. So that is this INA.current, whatever current is being drawn right now. So again, if I turn this back on, you can see I'm using 450 milliamps. Bump this up to 12 volts, and now we're drawing 2 amps. So getting close to the limits of what that can supply, and definitely beyond the limits of what that little ring light wants to be doing. Oh, that's blinding. And then this is a little check the INA 219 has in case the calculations overflow to prevent a catastrophe there. So that is it. I think I'll put a little bit more work into the firmware and maybe make this a slightly more standard method of connecting. I can light it up here. Instead of having to splice this in, I might show it using one of our breakouts, so you don't have to cut and splice as much stuff, just use regular wiring. But it's actually pretty minimal. I have a little fritzing diagram for it that I'll put into a guide, and this should be out pretty soon. I think it's a pretty nice, neat little gizmo that you can have as a pseudo benchtop power supply for very specific voltages, but all based on any power delivery supply that you have. So that is the new project. All right, so I think that is the main stuff I wanted to hit. I feel like I blew through super fast today because I was worried about not running long for whatever show is next. But hopefully, if you watched the full Charlin episode and started this a little late, you're getting close to back to real time. We got about 20 minutes, I think, before the next event. And I'll go over to the blog where we have some CircuitPython Day scheduling. Why can I never find this schedule? It's my fault. Someone gave it to me yesterday in the, is this it? Yeah, this will do it. There was a graphic. Oh no, that's about the okay. Someone tell me, once again, I think it was Paul Cutler yesterday, or the day before, who had a nice, neat link to CircuitPython Day scheduling. I'll see if, oh, it's Scott. Yeah, Scott's next. Thank you, Scott. That's even better than a schedule, is to actually have the answer from the horse's mouth. So Scott is going to be up, I think, at 5 o'clock Eastern time, 2 o'clock Pacific time. Are you doing deep dive on 2350 stuff? I think so. RP 2350. I don't have one of those yet, so I didn't do any showing and telling of those kinds of things, but I should say. Oh, it's Paul Cutler again with the save. Thank you. Happy CircuitPython Day. There's the thing I should have had bookmarked. Yes, Scott's on at 5, so you get a little bit of time here as I finish up. Before I go, I do want to remind you that you can go and get yourself, I'll turn off this light, you can get yourself a discount over at the store. Go to Adafruit.com, sift through some cool stuff. What cool stuff? Well, based on what I just showed you, we've got INA 219. You might want to get oops, that's the blog. Let me go to the shop. You might want to get one of these. High side current sensor breakout if you want to do this kind of a project. And then you can use either version of our HUSB dummy. I'm using the cheap one here, which does not have the dip switch package on it. Also does not have an on-off switch. The fancier one, which is right here, this has dip switches if you wanted to use it without any of this and without any soldering. If you didn't want to use I2C commands, if you didn't want to use the little solder bridges and you wanted to be able to change them at will, that's a pretty good option. And it has pins for an enable style on-off, so it's a little more straightforward to turn into a switchable supply. I just used the inline supply on mine instead. So those are a couple of the goodies there that you might want to pick up. And I'm also using the reverse TFT Feather ESP32S2 and one of these nice things right here, a little swirly grid. And this small 10 by 2 size fit this pretty well. In fact, you can see very popular for the 1 feather plus 2 breakout board style of assembly. And then I pick up some of these little, move this whole thing, some of these little little standoffs there, nylon hex M2.5 standoffs, perfect for setting up your board. Also, before I go, yeah, questions. I forgot to say, let's take some questions if anyone has them. I am happy to answer. Get that out of there. Let's go to the Discord there. Question for John Park. You plan on putting that cool power supply in a case? It's a good question. I was thinking of doing either a 3D printed case that maybe just covers the top and sides with the bottom being the swirly grid. So that would hopefully just be a print it upside down and to snap it on. And there are some existing example cases from the Ruiz brothers that are like individual feather reverse TFT, and there's a case for the HUSB 238, so I might grab those and kit bash them together. In fact, if you'd be interested in seeing that, maybe I'll do some of that process on the next show some of the 3D modeling of that. Of course, my other instinct is to build the case out of Lego, but that might be a little unruly in this case. Hem says, wonder if I can turn that into the basis of a DIY benchtop supply. Probably can stack the INA 219 and HUSB for additional space saving. Yeah, you could probably get this a decent bit smaller. You could flip, the two bottoms are basically flat on these, so as long as you don't short anything, because there's some through-hole terminal block things poking through, but you could probably, with one washer or a nut between them, get them upside down and maybe put them underneath the feather. You don't need any header pins on any of it. It's all wired through terminal blocks and the stemma QT port. let's see. Todd says, Tan New. Scott says, what is your favorite size of swirly grid? What would you change about it? Oh boy, I love this one. Do I have it right here? I think I took it. I think I stole it back into the house. Yeah, there's the half of this size. It's like the 10 by 5. Is this 10 by 10? Let me look. Let me look over here again. Let's see. 10 by 5. Yeah, I think that's my favorite size. That gives. Yeah, I think I brought that inside. I really thought I had one here. That gives you same width as these little skinny ones, but enough height so that you aren't hanging wires off everywhere. So I like to, in fact, you can see on this one, I have a zip tie holding this in place. So I like to put some strain relief on the cabling, and you can kind of do that nice and neat in line and still have space, because there's nothing you plug in that isn't at least like this much. Even on the little right angle USB cables, you've got about an inch or so that's always going to hang off that I kind of want to hide into there or give strain relief and bolt it onto there. So I really like that 10 by 5. What would I change? I don't have any changes, I don't think. They seem to work great. You know, I think they handle the semi-non-standardness of some of the board sizes really well, and that's the key. I noticed that there's a new system from Arduino that has some, I think all the boards are exactly the same size, like the little breakouts, regardless of what's on there. I think they're keeping them all with some specific standard spacing, so their boards are just circles and they're all even. The swirly grid, I know this was your intention, or at least I think it was, handles the fact that you don't always have a perfect world where every board is the same dimension, so I'm a fan of that. Yeah, I can't think of any changes, so maybe accessories for it. Maybe that's the main thing, is if we had more little like strain relief clip things, or maybe design some 3D printed case bottoms for them or feet for them, that kind of thing. Let's see, other questions. JP, do you have a favorite project, yours or others, from this year? Also wondering if you're hoping for any specific added features or technology for CircuitPython in the next 12 months. Good question. Let me change this very loud AC that's making it hard to think. There we go. Let's see, what was this year? What happened this year? I think Synth.io was all 2024, right? Here's how I find out what I did. I go to Learn, and I either type in my name or click on it. And, and I think this is sorted alphabetically by default, or what's the word for it? By date. So I can scroll back. Let me make this a little smaller. Optical drum sensor. This one, optical sensor drum track, was one of my favorites just because it involved a whole bunch of Lego building, figuring out, as well as getting 4 of these identical sensors to work with triggering stuff. Looked fun, had a fun result. Similarly, the automatic watch winder there. Of course, we did a lot of Memento projects. I actually really enjoyed doing this wireless remote with TouchOS-C thing. That was fun to dive into. Fader wave synthesizer, I'll tell you, it was a fun, that one was a fun KiCad project, and then I don't think I built a single other thing in KiCad after it, so I've forgotten 99% of everything that I learned on that, so that was a fail. I need to somehow start doing more frequent projects in KiCad, or I just forget everything immediately. Yeah, and this was a lot of Synth.io stuff. And I think we're going back now beyond. Oh, now the ordering is definitely off, because that Wakanda Forever game was a long time ago. So yeah, I think the drum track sequencers are my favorites. Added features or technology for CircuitPython in the next 12 months. That's also, I've started to do a couple projects that involve async I/O, which has been really helpful because I always struggle with trying to do two things at once. So maybe just diving into that deeper and seeing if there are either conveniences to make it even simpler to use. I'm a fan of some of the I hate to say it, but the large language model, ChatGPT style assistance on getting code things up and running quickly, but most of them I found get me up fairly quickly and then have major problems with them that I really need to solve, and then suddenly the thing is written in a way that I probably wouldn't have written it. So some have gone well, some haven't, but more assistance with getting things up and running, be it IDEs that help you, and maybe that's something I should look for, or some of the Copilot stuff that Scott was talking about. So yeah, those aren't really added features or technology for CircuitPython, but more around the edges of it for me using it. The only other main one is speed stuff. So and maybe this is just a matter of things like the RP2350 that are bringing more speed to the table, or more, PIOs and separate co-processing-y thingies that just make stuff faster. But there are projects where we run into, especially in the synthesizer projects, where we start to run into, or even some of the MIDI projects, like wanting to do display things and audio things, or retro gaming stuff. Like those are all areas where maybe the only areas where I'd be likely to run into wishing for things to be faster. I would love to dive into some retro gaming, handheldy style, or even with the RP2350, the fact that you'll be able to pretty easily go out DVI video to a monitor. I would love to build some simple games in CircuitPython. I don't think I ever have, maybe one, but like most of the gaming stuff with PyGamer, PyPortal ended up being inside of MakeCode for me, because it was more of a game development platform, and that's, I think, one of the big issues with doing game development, even of simple games, is that you kind of need a pixel editor and an asset manager and a music thing and a sound effects thing that can all kind of work together. And either you're just doing all of that stuff from scratch and managing it, or you're looking at some existing IDE. So it might be fun to try to get a little more into some of that in CircuitPython in the next 12 months. Let's see, John Nodge says, I bet the QtPy case would work too. Yeah, this is a good one to look at. I just got one of these, so that I'll look at that design. That would be a good one to look at for some of the putting together the power supply. C. Grover, hi, says Snap-on cases for the Swirly board family would be nice. Are there any proto boards made for Swirly Grid? Does a whole pitch and a perma proto match up? I don't think I have one here, but I think the half-size one may. The question is always, does it align enough to be square to it? Because I don't think I've ever run into something where I couldn't tilt it and at some point find a couple holes line up. But yeah, getting it straight on would be great. Let's see. Oh, one swirly request us to make the holes big enough to put a stemma QT connector through. I can't remember why, but for some reason I drilled out one of the holes on, is it on this one? No, there was something I was doing where I did drill a hole out. We're kind of stuck with M2.5. I wish we had done everything M3, but that's a pretty big hole for some of these boards. But you could just fit more through it. All right. John Nodge. So maybe the 10x5 with the center 6 squares in the middle row removed for cable routing. Yeah, or maybe those little ones, the center holes. What if those were M3 or M4? Then what? M4 starts to get into really being able to bolt some big stuff to it for attaching the cases and putting feet on them. In fact, I put on the bottom of my MacroPad, I screwed in some of these keyboard feet that we sell, and those I think are an M4 screw, so I had to make those big enough to fit. All right. And Gucciberg over in YouTube, any innovative input components that you're excited about? Yeah, you know what? And they list some examples: tactile switches, 5-way tactile, optical sensors. It's actually, I don't think it's that innovative, but we haven't really made them easy to use before, and it's the endless potentiometers. It's like a rotary encoder, but it has, I think, 5 pins on it. I can't remember how it works on the inside, but it's a smooth potentiometer that's endless. And I've repaired some synthesizers, sampler types of things that had them, and I thought they were great. I just sent, not too long ago, a request to Lamore to look into building a breakout for it and getting some for the store. So there's just a lot of cases where a rotary encoder, where it steps like 32 times or whatever, just isn't the kind of control you want. So endless pots would be pretty cool. I also really like the idea of doing little LED rings around and under encoders or those types of potentiometers. So maybe a breakout that does that. I think SparkFun had a breakout at one point that was like a ring LED with a encoder on top. But I like that kind of thing. All right. I think that's all the questions, yeah? Okay. Well, thank you. I was going to end so early, and now we only have 5 minutes for snacks before Scott goes on. So thanks, everybody. I appreciate everyone stepping up for CircuitPython Day and showing off their things and doing their shows. So, we got an answer from Steve. Hey, Steve. Steve, okay, you're on, says the infinite pots are 2 pots inside doing some sine cosine thing. Yeah, that's right. Rings a bell. Scott says, I want to do Lego collab projects. Yes! Okay, yeah, that is the other thing I want to do. There's a lot to be done there with the Technic and then moving the control over to CircuitPython in talking to our Technic Lego sets. So, yeah, that'll be a good one. We need to integrate Lego into CircuitPython. Thanks, everyone. I will see you on the other side. For Adafruit Industries, I'm John Park. This has been John Park's CircuitPython Day Workshop. Bye-bye.